Okay, let's continue with the second part of the video. We're just done with the generation of the Fibonacci series. We just did the program using the while statement. So once you understand the logic behind the program, it should be pretty simple if you want to write the program again with the for. So I think it's important if I could recall the logic. Like I said, it all starts with 0 and 1. The next number will be generated by the addition of 0 and 1, right? And then what happens is, you have 1 and 1, that will give you 2, 1 and 2, that will give you 3, 2 plus 3, that will give you 5. So I've just shown you the series. So let's do the same program using the for, right? So again, A is equal to 0, B is equal to 1, and then let's print A, comma, and then you have B, and then N is equal to, you have this comma, right? Let's leave a gap here. So the first two numbers should be printed like this. Now the next step is, since we are going to do it with the help of for statement, you will have for I in range, right? So again, how many times the loop should be executed, right? So we'll just give it down to 20 elements. So which means it has to be 9, right? So 1 till 8. The value of I will start with 1 and then it will end at 8. And you have 2 already here, and that makes 10 elements for the Fibonacci series. Okay, so again, the first, or rather the third element will be generated as A plus B. So we are going to use this same statement for generating all the remaining elements. It's just that, we have to assign, like I said earlier, we have to assign the value of B in A and C in B, because this is how the logic is, right? So you have here the print statement, which will print C, and then end is equal to, end is equal to, you have comma here, okay? And then, this is important, right? So you have 0 plus 1 as 1. So 1 will be the third element, right? And then, the next step is, you have B, comma, A, C should be assigned to B, and then B should be assigned to A, okay? And then you have B, right? And then again it goes back, it will print the next number in the series, right? So we'll just run the program. Hope, looks pretty okay to me. Okay, I've made a mistake, and the mistake is this, I guess. We'll just print the program. There you go. Okay, so you have 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. These are the Fibonacci series. So all you have to do is take a proper look at the very pattern of the Fibonacci series and then try to track the path of the program. And then you should be able to understand the match between what is needed and how it is implemented in the program. And then read the program 2-3 times. It's just a matter of time before you will get completely used to this program of generating the Fibonacci series. All right? Now let's go and check the next program. Print the given number in a reverse order. Okay? So this is like, if the input, if the number is 1, 2, 3, the answer of the program should be 3, 2, 1. So the program should be printing the numbers in a reverse order, right? The question is pretty simple. Okay, let's start. Let's say the value of n is equal to 1, 2, and 3. And then we have to use the while, remember? Okay, oh, I have some gap here. Strange. Okay, so let's have reverse number. Rn is equal to 0. Okay, I need this variable, which means reversed number. So ultimately, when I print the value of Rn, I should get the answer as 3, 2, 1. Okay, and then you should have the value of, okay, I don't need the value of a variable of I as such, while, and then I just write here n. I hope you remember this. The truthness value of n. Every object has a truthness value, right? If the truthness value of integer variable is 0, then it means it has truthness value of false. Non-zero values like 1, -1, -2, which means it has the truthness value of true. Alright? So when I say while n, as long as the value of n is non-zero, as long as the value of n is non-zero, I want to keep the loop running. Or you can also have this statement. As long as the value of n is greater than 0. Okay? So I think this is a little easier, so we'll stick to this particular test condition. If the value, as long as the value of n is greater than 0, I want to keep the loop running. Okay? I hope you got this. And now what I do is, the logic of the program is, I pick up the last digit. How do I pick up the last digit? If you divide 1, 2, 3 by 10, the remainder will always be the last number. For example, if you have 1, 2, 3, if you divide it by 10, 10 times 12 is 120, and the remainder is 3. So which means, if I divide a number by 10, the remainder will always be the last digit. Okay? I hope you got this. So we are going to use this. So in order to reverse the given number, I need to pick up the last digit, and then it has to be the first digit. This is how I do it, right? So how do I pick up the last digit is, I'll just write here z is equal to n modulus, and then I write here 10. I hope you got this. N modulus 10. N divided by 10, the remainder will be the last digit, right? So once I have the last digit, I do something like this. Rn equals Rn multiplied by 10, I'll explain. Rn multiplied by 10, and then I write here z. Now the question is, how can you just start writing the statement like this? Again, like I said, it's just a matter of getting used to, okay? And then, now look at this. What's happening here is, I get this 3. The logic is, I get this 3. Now, when I get the next number, which is 2, when I add these two, the answer will be 5. But I don't want the answer to be 5. Rather, I want the answer to be 32. Because I want to change 1, 2, 3 to 3, 2, 1. Okay? So, if I want to add 3 and 2 so that it lines up like 3 followed by 2, one way is I can multiply this by 10. If I multiply this by 10, what happens? 3 will change to 30. And then if you add 2, what happens? It will change to 32. Okay? So again, I multiply this by 10. It will change to 3 to 0. And then if I pick up, the remaining number 1, and then if I add it here, it will change to 3 to 1. Okay? So basically what am I doing is, I'm picking up the last number, and then I multiply this by 10. So it becomes 3, 0. And then when the next number comes in, which is 2, when I add it, 2 will line up nicely after 3. And then multiply 32 by 10, it changes to 320. And then 1 comes in, when I add 1 to 320, the answer will be 3 to 1. So this is the logic behind the program, right? So let's continue further. Just get rid of this for the time being. Alright, so this is the reason why I multiply Rn by 10, okay? And then, okay, by the way, this has to be 1, right? And then, now the next step is, I have to change the value of, I have to update the value of n. So I just have n is equal to n divided by 10. Okay, we just run the program first and then check whether I get the correct output or not. Okay. Okay, let's run the program and check. Okay, I got a little weird. This is 0, I guess. Okay, there you go. I made a little logical mistake. Okay, let's see whether it works for the other numbers. So it should be 432. If I change this to 456, you should have the answer as 654, right? So the program looks good. We'll try to understand whether the working of the program, all right? Okay, let's do it like this. We'll start. The value of n is how much? The value of n is 456. Okay, the value of n is 456. Just right here, n, right? Okay, n is how much? 456. Look at this z. Z is equal to n modulus 10. N modulus 10 means z is equal to 456 modulus 10. Okay, the value of n is 456. This will give me the value of 6. Okay, so you will have the value of z as 6. And then look at this Rn. Rn equals, Rn is 0. 0 multiplied by 10 is how much? 0 multiplied by 10 is 0 plus the value of z is 6. So you will have the answer as 6. Okay, I hope you got it till this point. And then now the next value of n. 456 should now be changed to 45. So that when I divide by 10, I'll get the remainder as 5. If I could just repeat, 456 should now be changed to 45. So that when I apply modulus 10, I'll get the digit of 5. Again, 45 should be changed to 4, so that I'll get the only digit of 4. So till this point, I hope you're okay. Now let's focus on this. N is equal to n divided by 10. What is the value of n? It is 456 divided by 10. You will get the answer as 45. Okay, 10 times 45 is 450. Whatever the remainder is, but the quotient is how much? 45. So the new value of n has now changed from 456 to 45. Okay, now we'll go with the next one. Up it goes. Now the value of n is how much? 45. Right? So this is now how much? Okay, 45. Right? So 45 modulus 10 is how much? 45 modulus 10, the remainder will be 5. 10 times 4 is 40. The remainder is how much? 5. I hope you got this. And then the next up is Rn multiplied by 10. The value of Rn is how much? Rn is 6. Be careful, right? Look at this statement, look at this statement. What is the value of Rn? The value of Rn is 6. Remember, it just deleted. 6 multiplied by 10 plus the value of z. The value of z is how much? 5. Alright? So 6 times 10 is 60. 60 plus 5 is how much? You have 65. Okay? So you have 6 followed by 5. And then the value of n is, now the next statement is 45. This particular statement, the value of n is 45. Remember, 45 divided by 10, the quotient is 4. So the 45 is now changed to 4. And then up it goes, the value of n is how much? 4. Okay? 4 modulus 10 is how much? 4 modulus 10 means, look here, 4 divided by 10. It cannot be 1, so it has to be 0. 10 times 0 is 0 and the remainder is how much? 4. Okay, so 4 modulus 10 is, okay, 4. So 4 becomes the new value of Z. Understood? And then, now look at the statement. Rn multiplied by 10. What is the new value? What is the latest value of Rn? It is 65. Alright? So the 65 multiplied by 10. So look at this. 65 multiplied by 10 plus Z. What is the value of Z? The value of Z is 4. So you will have 654. And then 654 becomes the new value of Rn. Okay? And then you have the value of N. Okay? The value of N is how much? It's 4. Remember? It is 4. Right? So when you divide 4 by 10, what will be the answer? Okay? When you divide 4 by 10, what is the quotient? You know, this is the floor division operator, right? So look at this. 4 divided by 10, what is the quotient? The quotient is 0, right? So the 0 becomes the latest value of N. Okay, so you have 0 here. Now let's check the condition. It has to be checked each time I finish the loop. 0 is greater than 0. The condition becomes false. Okay, so when the condition becomes false, the loop body has to be terminated, and then it jumps here. The value of Rn, look at this Rn here, the value of Rn is 654. So this is how I reverse a given number. The logic is pretty simple, right? Say initially it is 4, 5, 6. I pick up this, okay, and I store it in the Rn, right? And then I change 4, 5, 6 to 45. Okay, I pick up this, and then before I add it, I multiplied 6 by 10, so that it will change to 65. And then I change 45 to 4. I change 45 to 4, and then before I pick up this, but I multiply this by 10, and then I add 4. So finally, when the condition becomes false, you need to leave the loop, right? So I hope you have understood this. If not, watch the video again and again. You will soon understand. Now let's go for the last program. The last program is almost same as this program, okay? So just print the sum of the individual digits of a given number, right? Say if n is equal to 7, 8, 9, the sum of individual digits is 7 plus 8 is 15, 15 plus 9 is 24, right? So the logic is pretty much the same. It's almost the same. In fact, the last program is much easier than the second last program, right? So let's check out. So let's do this using the while again. Sum is equal to 0. Okay, I'll leave some here. All right. Okay, so again you have while n, or you can write n is greater than 0, right? Now the question is, how do you pick up, you know, the individual digits? How do I pick up 9? How do I pick up 8? How do I pick up 7? Like I said, if I divide 7, 8, 9 by 10, the remainder will always be the last digit. That's, you know, for sure, right? So this is how I get the 9, and then I add 9 to the sum variable. Now the next up is change 7, 8, 9 to 7, 8. Change 7, 8, 9 to 7, 8 by dividing by 10, and then the quotient will be 78. And then again apply the modulus operator, pick up the last digit, which will be 8, and then add it, and then again change 7, 8 to 7, pick up the last or the only number, and then add it, right? So Z, pick up the last number. How do you do this? 9 modulus of 10. So 7, 8, 9 modulus 10, that should give us the value of 9. Okay, and then add it to sum. Sum plus you have z. Right? Now let's update the value of n from 789 to 78. How do you do this? Is n divided by 10. Okay? So that's pretty much. Let's print the value of sum. You should get the answer as 24, right? So we'll just change the value and check whether it works alright. For next number it should be 30, right? Okay, there you go. You have the answer as 30. So again, we'll just simplify the number to 3, 4, 5 and then run it. I get the 12 here. Let's do this real quick. I'll not write the numbers. N is 345. 345 is greater than 0. The condition is true. 3, 4, 5 modulus 10. The answer is 5. 5 is assigned to Z. Sum is 0. 0 plus 5 is how much? 5. N 345 divided by 10. The quotient is 34. Okay? Up again. 34 greater than 0. The condition is true. 34 modulus 10. 34 modulus 10, you will get the last digit of 4. Okay? So you have Z as 4, sum as 5. 5 plus 4, we will have 9. Alright? And then N, 34 divided by 10. 34 divided by 10, the quotient will be 3. And then 3 greater than 0, the condition is true. 3 modulus 10. 10 times 0 is 0, 3 minus 0 is 3. So you have the value of Z as 3. 9 plus 3 is 12. Alright? 12 here. And then 3 modulus 10. The quotient is how much? 0. Quotient is 0. Okay? So you have 0 here. 0 greater than 0, the condition is false. Alright? So come out of the loop and then when you print the value of sum, you will get 12 here. Okay? So the last two programs are pretty much the same. Alright? So I hope you have managed to understand all of today's program, hopefully. Right? So with this, I would like to end today's video on the implementation of the iterative statement of the while. Okay? So at the end of today's class, you should feel relatively comfortable with the usage of not just for, but while as well. And in the next class, we'll continue further with some little more variation of while and for. Till then, take care.